I welcome all of you on the platform of YourPedia Education, and this particular video is related to the upcoming exam of ATC, that is Airport Authority of India, and this particular lecture is of physics, and in the physics also I am going to discuss with you one of the very important topic, that is electric flux and what is a Gauss law. I told you that there is a strategy in physics. The civil and mechanical engineers or chemical engineers, those who have not done the topics of electrostatics, magnetism in their graduation, they should start with these topics. They are simple topics. In fact, entire physics is of 11th and 12th standard physics, which you have already done in your this year before your graduation for competitive exams. So the topics are very simple, and the kind of questions which are asked in your airport authority, they are straightforward question based on formulas and some concepts. Try to understand. If you understand this lecture fully, and if you are in position to answer the questions, you will be very comfortably, you will be in position to complete entire physics. I believe in 40, 50 hours that can be done, because I think this lecture is going to be 20-25 minutes. So if you are in position to understand it, you will be in position to understand entire physics. Physics is a simple topic. Now I'll try to make some sense of the meaning of it. Flux means something which is flowing out. Flux means something which is going out from some particular surface or some particular area. Something which is coming out is called flux. Here it is electric flux. Electric flux means electric field lines coming out from the surface, that is called electric flux. Why do we have electric field lines? We have already studied that electric field lines can be because of the electric charge somewhere. Suppose there is a charge, as you know, magnetic field lines are there. If there is a magnet, there are magnetic field lines. If there is a charge, positive or negative charge, there are electric field lines, and those electric field lines constitute electric field. So there will be a charge, because of charge there will be electric field, and in the electric field there will be electric field lines. The density of those lines, electric field lines, define how strong is the electric field or how strong is the charge in that particular field. That is how it is defined. So we are talking about here electric flux means electric field lines. How many electric field lines are coming out from the area? So maybe if I can give you the definition, though I will be giving you that definition later on, we will be writing electric flux as phi E. E stands for electric field, phi means flux. Electric field lines which are passing perpendicular to the plane surface. There is a surface, perpendicular to that surface, how many lines are passing, that is called electric field. Let us say this is one particular line, electric field lines, and if I give you some area, let us say this board is area, and this line is passing through this particular board perpendicular to the plane of the board. So this is the board and this is the plane of the board. Now this particular pen is perpendicular to the plane of board. Pen is a line, electric field is also a line. So this is the perpendicular to the plane of this particular board, and hence I will say this is electric flux. 1 line, 2 line, 3 line, 4 line, 5 line, 6 line. So suppose there are 20 electric field lines perpendicular to plane, electric flux will be 20, something like that. Now before I come to electric flux, let me give you some basic ideas of area and line. What we should know is line tells you about direction. Whenever I draw a line, I give you a direction. So this particular thing, this line which I am making, if I stand at this point and draw a line which is a tangent, then this tangent is going to give me some kind of direction. So line has two things. Line has magnitude and line has direction also. And these two things if you have, you are a vector. So line is a vector. So remember always that any line, whether it is a straight line or it is a curve or something like that, this has a direction, this has a magnitude, so that comes under the category of vector. Now our topic is not related to line, forget about that. Our topic is related to area. So even if you do not understand what is line or something like that, we are not discussing it here, we are discussing about the area. Area is also vector. Now best way to understand area, whenever you want to find out the area of a rectangle or triangle or something, you need to multiply two dimensions. Can you tell me, if I give you this A, this B, what will be the area made from these two lines? You know, obviously if these are the areas, then I draw lines this also and this becomes the area. There are two sides of this rectangle, one A, another is B. A multiply by B. If I multiply A with B, then I get area. That is very simple. But area is not only having magnitude. In this case, magnitude of the area, can you tell me what is the magnitude of area? Magnitude of area is A into B, that is the magnitude. One line into another line, one side into another side. Similarly, circle has a area, similarly triangle has a area. So every plane body has a area, whether it is in the form of some kind of predictable shape or it can be any shape. Even if I give you this kind of shape, you know, this is a plane, so it also has area, and area has a magnitude. Okay, now magnitude is okay. What about direction? Because area is a vector. What about direction? Just imagine this side. If I go from O to A, direction is this side. If I go from A to B, direction is this side. Now suppose I give you two vectors and ask you to calculate their vector product, because only vector product gives you vector. Scalar product does not give you vector. Listen carefully. Whenever I multiply two vectors, there are two ways to multiply two vectors. One, dot product, another cross product. Dot product does not give you vector. So two lines which are vectors, if I multiply these two lines as a cross product, I get another vector. So area is a cross product of two lines, A cross B. Can you tell me what is the direction of that vector? Now we have done right hand screw rule, right? Take the right hand curling the fingers, that also is there, right? So if you curl your fingers from A to B, then thumb gives you direction of the vector. Now take screw. If you take a screw moving from A to B, from A vector to B vector, then you get this particular thing. So that way you will find the direction of vector, area vector. So what you need to understand is, in area there are two sides, and when you cross product these two sides, when you take the cross product of these two sides, you get the area of that particular direction of that particular area vector. Remember one thing, even if you have not understood it, remember one thing, area is a vector, direction of the area vector is perpendicular to plane of that area, perpendicular to this plane. Why? Because vector product is perpendicular to the two vectors. This is one vector, this is another vector. Now A cross B is perpendicular to A and B vector. You know that. So that means the area is a vector and the direction of that area vector is perpendicular to the plane of that area. Now let me ask you a question. If this board is a plane surface, this board is a plane surface, I want to calculate the area of this board. How shall you calculate? You will say, sir, its height into its length is area. Done. What is the direction? Direction is outward or inward? What is your answer? It is outward or inward? It can be anything. It can be outward also, it can be inward also, depends how you are moving. So remember, even outward direction or inward direction, both are acceptable in the area. So am I clear? Line is a vector, area is a vector. Done. Let's go forward. Let me give you some questions here. I am giving you this shape having x dimension, y dimension. Now there is an area vector made up of x and y. Can you tell me what will be the area vector? Sir, x into y is the magnitude, x into y is the magnitude, and it can be plus k or it can be minus k. Outward, inward, anything. It can be plus k, it can be minus k. This for two dimension is okay. For two dimension it can be this side or that side. But the moment I go to three dimension, now that is very important, and listen it carefully now. In 3D shapes, 3D area is taken outward. This is very important, and mark this in your memory. Do you see this as a cylindrical surface? How many areas this cylindrical surface has? Sir, top area, bottom area and curved area. Okay, done. Can you tell me what is the top area? Sir, pi r square. What is the bottom area? Pi r square. And what is the direction? That is the best part. Direction of the area for three-dimensional body is always taken outward, not inward. So this is outward, and yes, curved part also has outward direction. So there are three areas of the cylinder. How do you calculate the surface area of the cylinder? Pi r square, pi 2 pi r into L, right? So all these three areas, direction of all these three areas is outward, it is not inward. So that is something which is the most important thing for 3 dimension. For 2D it does not matter. For 2D whether outward, inward does not matter. But for 3D it is always taken outward. I hope this is clear to you. What about this? See this diagram also. Now I am giving you a cube. How many faces a cube has? 6 faces. Each face, let us say, of size A. So what is the area of shaded surface? A square. A square. What is the direction? Outward, 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 outward. So all 6 sides the area will be outward. That is how actually for 3-dimensional things it is calculated. And on the basis of this small concept, many questions are asked. Even in your airport authority, you can expect a small question on the basis of this small concept. Let me go forward. Now we are coming back to our topic, electric flux lines. What is electric field lines? What is electric flux? Electric flux phi E is nothing but total number of electric field lines which are passing perpendicular to a plane surface. We will define the surface. Now I am giving you 3 diagram here. See carefully. First diagram mein electric field is same, E1. First diagram electric field is E1, area is A1. Second diagram mein electric field is E1, area is A2. Third diagram mein area is A1, this area which I am giving you, now it is A1 only, but the electric field is E2. Can you say these electric fields are looking like same? How do you see the electric field? Sir, the density of lines tells us about the intensity of field. If the density of line, and how do you measure density of lines? Sir, the space between 2 lines. Are these 2 lines equally spaced here and here? Yes, equally spaced. So that means electric field here and electric field here is same, but area is not same. This area and this area is not same. Okay, what about this? Sir, this area A1 and this area A1 is same. Visually it is looking like same. This area looks like large, but electric field lines are very close. That means dense. That means electric field looks like strong. Now how do you calculate, how do you define the electric field lines? You define the electric field lines, electric flux, as number of electric field lines passing perpendicular to particular surface, perpendicular to the plane surface. Now can you tell me how many lines are passing through A1? Sir, 2. So what is the electric flux here? Phi 2. How many lines are passing through area A2? 4. So what is electric flux? Sir, 4. How many lines are passing through A1 area? 4. So what is electric flux? 4. That means I can change electric flux by changing 2 things, either of the 2 things. I can change electric flux by changing either of the 2 things. One, I may change electric flux, which is number of electric field lines passing perpendicular to plane surface. This is the plane surface, perpendicular to that. Either I can change area or I can change electric field line, electric field E. Either E or A, if I change, electric flux gets changed. That means electric flux, which I defined as phi, is a function of either area or electric field. What is electric field lines? This charge ke through I was trying to explain you that if I give you a charge, then you know every side electric field lines will be there radially outward. So you get, that is the meaning of electric field lines. All of you know what is the electric field lines. So that means electric flux depends upon either area or electric field, and the formula is electric flux is E dot A. This is a dot product. Dot product, later on I will tell you, dot product means E into A into cos theta. That is how I define the electric flux. So our basic understanding what is electric flux is electric field lines, electric field intensity and area multiple of these two gives me electric flux. Now, let me give you this particular diagram once again. If I give you one surface area, how do you find out the direction of area of a plane? Draw perpendicular on that. So suppose this is a plane, black colored diagram which I made, that is a plane surface. The area of that plane surface is marked by this arrow which is perpendicular to this plane. So vector A is the area of this particular plane vector. And now electric field E is having some angle theta with this. So electric field is at an angle theta to the direction of area vector. Direction of area vector, how do you calculate direction of area? Sir, perpendicular to the plane of area is a direction. So this A is perpendicular to this plane, if you can visualize the diagram, and E is making angle theta with it. So how do you get EA cos theta? There are two ways to do that. Let's resolve electric field in the direction of area vector and perpendicular to area vector. When I resolve it in the direction of the area vector, that component is E cos theta. So maybe this E cos theta is a component of electric field along the area vector or perpendicular to the plane of surface. Listen carefully. Either I can say along area vector or perpendicular to the plane of surface. Why I say that? Because the area vector is perpendicular to plane of the surface. So if this is the plane of surface, perpendicular to that is area vector. So which component is along a vector? E cos theta. So that component of E which is along area vector or perpendicular to the plane of surface into area gives me the electric flux. One of the question which very frequently is asked in Airport Authority of India exam is the dimensions. What is the dimension of this? Can you tell me what is the dimension of area? You know L square, M, L, T are the basic three dimensions. Then if there is a current and or current also has a dimension. How do you define current? Current is a charge per unit time. Flow of charge is called current. So charge per unit time is called current. We have dimension of current. So current is written as ampere. We have dimension of current. Now charge is having dimension of ampere into time, that is Coulomb. Charge, unit of charge is Coulomb. So 1 Coulomb is ampere into time, A into T. So A into T is the dimension of charge. What is the dimension of length? L. What is the dimension of area? L square. What is the dimension of force? ml T minus 2, mass into acceleration. This T is the time. Now what is electric field? Electric field is nothing but, electric field is defined as electric force per unit charge, or electric force is equal to electric field into charge. Coulomb's law, you will read this. Coulomb's law in the electrostatic, whenever there are two charges, then the Coulomb's law 1 by 4 pi epsilon naught q1 q2 by r square. Now if the electric field is E, then E into charge is electric field, electric force. So that means electric field is electric force per unit charge. That means electric field is written as Coulomb, Newton per Coulomb. Newton is the unit of force and Coulomb is the unit of charge. So electric field is nothing but Newton per Coulomb. So now you have dimension of E, Newton per Coulomb, you have dimension of area. If you put all these values, then you get the dimension of electric flux also. So what is dimension of electric flux? Sir, this is nothing but Newton ml T minus 2 into meter square L square over Coulomb. Coulomb is nothing but A into T. A is the ampere. So eventually if you solve it, this is the dimension of electric flux, which is important, and please remember it, because one of the question will be from dimension in the exam. I hope this is clear to you. Let's go forward now. Can you find out what is the electric flux of this? I am giving you question now. Can you find out what is the electric flux of electric flux through this circular plane surface? There is a plane surface which is circular of radius r. So what is the area? Sir, area is pi r square, okay, and electric field E is making an angle 30 degree with this plane surface. Electric field is making an angle 30 degree with this plane surface. If this is the plane surface, electric field is making angle 30 degree. Okay, what is electric field? Electric flux E dot A. Okay, that is E A cos theta. Can you tell me what is theta? Theta is the angle between E and A vector. Which is E vector? This is E vector. Which one is A vector? Now that is a catch. Which one is A vector? Sir, area vector is perpendicular to the surface of plane. This is the A vector. This one is the surface, this is a plane. Perpendicular to that is the area vector. Now can you tell me what is theta? Theta is 60 degree. That means here you have to say E pi r square into cos 60 degree. And what is cos 60 degree? That is 1 by 2. So do not put 30 degree. Be careful. What is this theta? Theta is the angle between A and E, and A is the vector which is perpendicular to plane. Find the total flux through a cube. Now I am giving you a cube which is having 6 surfaces. Each side is A, and this cube is kept in the electric field something like this. One of the sides of the cube is parallel to electric field which is along the x-axis. Give yourself 1 minute and tell me what is the electric flux through this cube. Tell me what is the electric flux through this cube. Now remember one thing, if electric field is perpendicular to the area that is perpendicular to the plane of area, that means it is in the same direction as that of area, that electric flux is E into A. But suppose electric field is perpendicular to the area, electric field is perpendicular to the area or the plane surface, then electric field is perpendicular to the area of the plane surface, direction of the area, then electric field is 0. Let me tell you that. What I mean, I make a diagram. Can you tell me for this area what is the direction of area? Direction of area is this. Okay. What about this? So direction of area is this. Now see carefully, for both these surfaces, top surface and bottom surface, this is the direction of area and this one is direction of electric field. Theta is 90 degree, cos 90 is 0. No electric flux. Obviously common sense. Is there any electric field coming out from this or from this? Nothing is coming out. Similarly, there are 2 more surfaces in which same thing is going to happen. One is this, one is this also. This is also area. Understand? This particular surface and this particular surface. Again, this area is perpendicular to electric field and no electric flux. There will not be any electric flux. The moment we go to this particular surface, what is the area vector? Sir, this is the area vector. What is the electric field? Sir, electric field is also in the same direction. What is theta? Theta is 90 degree. And if theta is 90 degree, theta is 0 degree, E and A are in the same direction. So electric flux is how much? Electric flux through this surface is E into A, cos 0. Done. Is there any other surface through which electric flux will be there? Yes, this surface also. How much? EA. So should I add EA and make it 2AE? Wrong. It is not EA plus EA. In fact, I told you that area in this case will be this one. Electric field is this side, area is this side. See this carefully. Direction of electric field is this side and area direction of area is this side. So direction of E and direction of A are opposite, and hence this is cos 180 degree is minus EA. So this becomes minus EA, this becomes 0. So total electric flux through this cube, if this cube is kept in the electric field, total electric flux in this cube is 0. That is understood. Because if these lines are entering, these lines are going out also. It is like discharge only. What is the, this, if this is going out, this is coming out, so net electric flux is going to be 0. So you need to understand that, electric flux has a direction, electric flux is calculated as dot product of E and A, area has a direction, and the direction of area, as I gave you that very important line here, that you need to keep in mind that area is taken outward. Area is taken outward means that if I give you this particular diagram, you see this carefully, area for this surface is this side, whereas area for this surface is this side, and hence both the areas are opposite. And if I put this in the electric field, this flux and this flux are going to cut each other, and hence no electric flux will be there. Can you give me some idea about what will be the electric flux in this now? Any idea about what is the electric flux through this? Okay, this is one area, this is another area, right? So what is this area? So this is pi r square. What is this area? So this is also pi r square, right? This electric field is E. Now this electric field, this area is perpendicular to electric field, so there will be no actually flux in this. So if you see, this area and this area are opposite, this is this side and this area is this side. Again electric flux is going to cancel it out. So no electric flux, again this is 0. And now we have come to a very important concept, and that concept is the net flux through closed surface is 0. Net flux through closed surface kept in electric field, if I can write that, is 0. So the concept is, if I give you closed surface, 3-dimensional body, cube, spherical shaped body, anything, and if I keep it inside the electric field, net flux is going to be 0. But there should not be any charge. There should not be any charge in this. Now let me give you another question. Now I am giving electric field which is function of x. Let us say this is x-axis, and I am giving you electric field as E is equal to E naught into x. Sorry, this is the graph. So I am giving you this. Electric field is E naught into x. So it is changing with x. Now can you tell me what is this area vector? Sir, this side. Okay, what is this area vector? Sir, this side. Will both cancel out again? No. Why? Because this electric flux, let's say phi 1, and this electric flux phi 2. Phi 1 is minus E naught x. X in this case is A into area. Area is same. Minus because area and electric field are opposite to each other. Angle is 180 degree. And what is x here? X here is A. What is x at this point? X at this point is 2a, but that is positive, so it is equal to E naught 2a into, I hope you understood it. Area both sides is equal, angle 0 degree, angle 180 degree, but here x is a, here x is 2a, and E naught is basically E is a function of x. So that way I am going to get here is E naught into 2a into area, whatever area of this surface we have, that is a square. I hope this is clear to you. So this is how, and there will be no flux from other 4 surfaces as we have already seen. But suppose there is a charge inside the spherical shell now. If there is a charge, then how to calculate the electric flux? Now understand carefully. This is the formula we have already done. Electric field. Electric field because of a charge q, that is the formula which Coulomb's law, from there only we derived it, basic formula of electrostatic. Electric field because of charge q is 1 by 4 pi epsilon naught q by r square. You know all the terms due to point charge. Now what will be the electric field at this small elemental area? Now because of the charge there will be electric field lines everywhere. So there will be electric field lines everywhere because of this charge. There are electric field lines which are everywhere like this. Electric field lines are everywhere. Now if I want to calculate the electric flux, let's take elemental area dA. I gave you elemental area dA, and through this elemental area, let us say the electric field which is going out is E. This is the electric field. At distance r, electric field is E. So what is the electric flux? Sir, this is E into dA. Okay. And what about here? Again E into dA. This is dA. This is electric field, and electric field also has a direction, and that is for positive charge it is outward, as you know. So E into dA, E everywhere is same because on the perimeter R is same, 1 by 4 pi epsilon naught is constant, charge is Q. So everywhere dA is same. So total electric flux will be how much? Total electric flux will be integration of E into dA. I integrated, I get E into dA. Now if E everywhere is same, I can take EA common. E is everywhere same. How do I know E is everywhere same? Because R everywhere on the periphery of the spherical shell, E is same. What is the surface area of the sphere? 4 pi R square. Now what is this E? This formula 1 by 4 pi epsilon naught Q by R square is the Coulomb's law only for electric field, right? So into pi R square, 4 pi R square, and eventually this gives Q by epsilon naught. So what we understand is, if I give you a closed surface, now listen carefully, and then next lecture is a Gauss law, and we have come to the Gauss law. Now Gauss law is nothing but next extension of electric flux. Gauss law measures the electric flux through a closed surface if a charge is kept inside. So suppose there is a charge enclosed by a surface, closed surface, then the electric flux because of the charge through that closed surface is Q by epsilon naught. Next lecture I am going to tell you, and Gauss law se positively question will come. From these two lectures positively one question will come. So next class I am going to tell you that shape of the surface does not matter. Whether it is spherical or it is cubicoid, shape does not matter. Only thing you need to see is how much is the charge. And where that charge is kept, that also is immaterial. If I put Q here, wherever you put, it is Q by epsilon naught. Epsilon naught, as you know, is a constant, and permeability का भी dimensional formula पूछा था पिछली बार. Now you know the dimensional formula of phi, you know dimensional formula Q, you know dimensional formula of E also Q. From here also you can find it out. So dimensional formula भी यहीं से आएगा. So accordingly this is the Gauss law. Closed surface, charge is kept inside. What is electric flux? This is how it is to be done. That is more than sufficient for you to prepare for your this exam, and this is only is required. Physics is a very simple subject. Keep revising with us, and I am very sure you will score very high in your upcoming exam. All the best. Thank you.